Good afternoon, I am Suma from Rathanan College of Arts and Science. Today I am going to handle the topic stack. Today we are going to discuss about what is stack, what are the operations of stack, what is push operation in data structure, what is a pop operation in data structure. Stack, basic principles, operation of stack, stacks in array, stack in linked list, and applications of stack. Stack is an abstract data type. A stack is also called as last in first out system in linear string in which insertion and deletion can take place at one end called the top. Here we can take an example of stack, that is, here we have added an element 1, that is push. Push means insertion of element to a stack, and here we are deleting element called 4, that is a pop operation, that removing an element from the top of the element. And the three concept and basic operation of stack is push, pop. Push means a deleting, insertion. Push means insertion of element to a stack, and pop means deletion of element from the top of the stack. Let's give a real-time example that we are arranging book from one top of the another and arranging of the dishes from one to another. Here we can take the last in first out, that is who is entering is last will be getting out of the first of the stack, and here the stack and here the stack. Here we are adding an element to a stack is known as push operation, and we are deleting an element from a stack is known as pop operation. Can be implemented means of array structure, point and linked list, and stack can be either be fixed or dynamic. Operation stack is push, pop, create, and is empty and is full. As we know, as we declared as that, it is an empty stack. Adding an element is push, and again we are adding element 1 and 2, that is not push, and again adding 3 elements 1, 2, 3. Now it's an operation is push, and now we are removing an element 3 is known as pop. Basic operation, stack operation may involve in 3 operations, that is push, pop, ஒன்றுமே வரமாட்டேங்குது. பாஸ் பண்ண முடியாதா? Stack operation may involve initializing stack using it and deinitializing its part. Create, push, and pop. Create means create a new stack. As we know that push means inserting an element and pop means deleting an element. When data is pushed onto a stack, to use a stack efficiently, we need to check the status of stack as well. For the same purpose, the following functionality is added in the stack: is full and is empty. Is full means whether the stack is fully with the element. Is empty means whether the stack is contained a 0 element. Here is a syntax: void push stack star s. Star is a pointer that is for the memory allocation. Void push means we are inserting an element to a stack. Int pop stack means we are removing and return the top of the element. Pop means removing an element from a stack. Void create stack means here we are using the word create, a keyword create, to create a stack. Int is empty, here we are using the is empty to check whether the stack is empty. Is full means we are using this keyword is full to check whether the stack is full or not. Let's take an example. The stack is 0, 1, 2, 3, 4. Here is an array means. Array means we always initialize with a value 0 because its index is begin with 0. That is, if we are taking an element of 5, its index is 5, 0. That is, the memory allocation will be 0, and the stack means 5, 6, 9 and 2. Here 2 is the top. We are using always the top for removing or insertion of an element. Stack abstract data type. As we know, abstract data type is used to show only the needed elements. The implementation will not be shown. So as we discussed before, last in first out, here we have already added many elements 1, 2, 3, 4, 5, 6. Here the last element is 6. So what we have to do means when we are popping an element, it should be removed from the top. So we are using this keyword top means a stack. So 6 will be removed, that operation is known as pop. Stack data structure last in first out. Last in first out, for example, we can take arranging a books one by one. We cannot remove the element from the bottom, we can only remove from the top one by one. So as we know, as we discussed about 5, 8, 6, it is arranged in a array manner. Here it will be 0, 1, 2, 3, 4, 5, 6. So when we have to take push 4 means it will be 0, 1, 2, 3, 4. 15th element will be inserted, and same process will be go on. Push operation, push 4 means 4 will be inserted, it will be this side because here is the top and here is the bottom. And next is push 15, 15 will be inserted. Push 10 means the 10 will be inserted. Again push 6 means 6 and go on. And pop operation means pop 5. From the top, the pop will be taken as 5, 5th element will be eliminated, and 8 will be next eliminated from the stack. Stack using a linked list. Linked list means linking from one node to another one. That is, it will be having the address for the another node. So here is the node, node 2 and node 3 and the null. Here is the data and here it will be having the address. Applications of stack, that is expression evaluation, expression conversion, syntax parsing. Expression evaluation means we can evaluate prefix, postfix and infix. Stop. இங்கிருந்தே repeat பண்ணிக்கிறேன். அது நின்று பேசினல. Okay, application stack. Applications of stack, expression evaluation, that is stack is used to evaluate prefix, postfix and infix. Prefix means normal, the word, that is operand and operator. Operand means A or B, operator means plus, minus or whatever the symbols we are using for adding. So if it's come the plus AB means it's prefix, postfix means AB plus will be the postfix, infix means A plus B will be the infix. Next, expression conversion, that is we are converting from one form to another, that is prefix to postfix to prefix or infix to postfix or prefix. Syntax parsing means when we are doing many compiler use stack for parsing the syntax of expression program blocks before translating one low level code to another. Backtracking. Backtracking means normally undo and redo sequences. We can take an example of Sudoku. When we are doing Sudoku, we haven't found a exact number we are adding. We will what do means we will remove the number and we will be redo. That is the same process will going on backtracking. And page visited history in a web browser. When we go and search for a history, we can see that already visited pages will be there. That is also an example of backtracking. And parenthesis checking means when we are writing a program, there must be a starting parenthesis and ending parenthesis. Without a starting and ending parenthesis, we can't execute a program correctly. So that is the parenthesis checking. String reversal. It's a best example for stack. When we are adding an element A, B, C, that is a string, we can take a string. In reversal means what it comes, outcome means C, B, A, that is the string reversal we are using stack, that is push and pop operation goes on in this stack. Function call, stack is used to keep information about the active functions or subroutines. எவ்வளோ மினிட் இருக்கு? 2 நிமிஷமா? ஒரு செகண்ட் அடுத்த ஸ்லைட் என்ன பார்த்துக்கலாமா? பாரு. ஓகே போகலாம். Okay, so this is the best example for function call. Here we are having an empty stack. So here what happened means a main function is getting. Here what again we means a foo function is get ready. So what happened means the file will be taking here again a bar. So here the stack is full. Okay, now when we return to that means what happened means bar will be gained everything, so it is eliminated, and again foo came here, foo is getting everything, it is eliminated, and the main, again it comes to the empty stack. Same thing goes on in a backward mode. This is a function call. Next, declaration. In array and linked list we are going to see. In array means a defined maximum size, that is maximum size of array will be 100, and struct LIFO, that is just we give a name LIFO, int SD, that is for an array maximum size that we have initialized here 100, int top, that is we have already said that stack will be having keyword that is top. Here typed of struct LIFO stack is, we have already declared a array for mode of stack. And linked list means struct LIFO int value struct LIFO star next. As already I have said, star is a memory allocation. Why we are using next means in linked list we have to go for next node. So we are using next, and typed of struct LIFO stack star top. Next, how we are creating a stack using array and linked list. Void create stack star is, yes, top is equal to -1. We are checking here whether the stack is empty or not, and S top points to last element pushed in, that is initially -1, that is pushed or not. Next, linked list. Void create stack star, that's double star is to increment the memory allocation. Star top is equal to null. Array. Void push stack is int element. If S is equal to maximum size -1, print stack is overflow, exit -1, else yes top plus plus, yes st top is equal to element. Here it shows means if s top equal to -1, we have to know that flow போயிடுச்சு. S top, okay. If S top is equal to maximum size -1, print f stack overflow exit -1, else stack top plus plus S top is element. That is, if the maximum size is -1, then we have to say stack is overflow, that is stack is filled with elements, else we have to add an element. Poduma? Thank you. Okay. Next, void push stack starter top int element stack is equal to new equal to stack. Malloc is the memory allocation size of stack. If new equal to null, print f stack is full, exit -1, new value equal to element, new next is equal to top, star top is equal to new. Here we are using this format for the array and linked list. So today we have discussed about the stack operations and about their representation of array and linked list and how the stack is worked. Thank you.